Today we'll be looking at an interesting geometry problem. Start with square. Construct a quarter circle from the bottom right corner, connecting the first and fourth corners of the square. Construct another quarter circle connecting the second and third corners of the square. We need to find the area of this lune-shaped shaded region. The problem statement says that a square is constructed using two quadrants of a unit circle as shown. Find the area of the shaded region. I encourage you to pause the video and see if you can figure it out on your own. So how can we work it out? Like many geometry problems, we'll begin by making a few constructions that make the calculation easier. The only information given in the problem is that we have quadrants of a unit circle and a square. A unit circle means the radius is 1. Now, doing just one step brings us closer to the solution. Draw lines from where the arcs meet down to the bottom corners, forming a triangle. Since the radius of each circle is 1, both sides of the triangle have a length of 1. Watch how the radii move along the arcs, forming the shape of the triangle. Rotating these two lines along the quarter circles gives us two important conclusions. First, we have an equilateral triangle with all sides equal to 1. Second, the area of the square is equal to 1. Since we have an equilateral triangle, this angle is 60 degrees, which means each of these curved pieces is 30 degrees because the quarter circle is 90 degrees total. Now, by having all this information, we can form a simple equation. The area of the lune plus the area of the triangle plus the area of these two sectors equals 1, because the area of the square is 1. So for the area of the lune, all we need to do is subtract the area of the triangle and the area of the sectors from 1, and we'll have our solution. Now I can write this in equation. Area of the lune equals 1 minus the area of the triangle minus 2 times the area of a sector. For an equilateral triangle, the area is square root of 3 over 4 times s squared, where s is the length of a side. For a sector, the area is 30 over 360 times pi times radius squared. In this problem, we have s and r equal to 1. Substituting these values and simplifying the equation will give us area of the lune equals 1 minus square root of 3 over 4 minus pi over 6. That's it! We've found our solution. Subscribe to this channel for more problems like this. Until then, keep thinking outside the box.